the topic of hydrogen has been discussed in hundreds of forums. In fact, I keep joking now that the only people who are making any money in hydrogen are the people who hold conferences. So, it's a difficult animal to tackle. We hear a lot of good things about hydrogen, and I've been a big fan of hydrogen for the last 15 years, and I still am. But, as my hair grows gray, reality brings in more, kicks in. Hydrogen is touted as the Swiss knife of energy transition. You can convert electricity, sort of green electrons, into molecules, which is hydrogen, at a fairly good efficiency. A really bad electrolyzer is at least 70% efficient. You can then use hydrogen for a whole variety of applications. It's a great reducing agent, good fuel, very high, gravimetric energy density. Can be used in a whole lot of sectors, from refining, fertilizers, chemical industry, materials industry, mobility, power, so whole lot of applications. If required, you can also convert hydrogen back into electricity by really efficient devices like fuel cells. Again, a really bad fuel cell has an efficiency of 50%, which is not bad compared to a diesel engine or a CNG engine. And yet, hydrogen is always called as the fuel of the future. And God knows when the future will come, right? And there are good reasons for it. There are difficulties of hydrogen. It is a first element in the periodic table, so very low molecular weight, that means very low density. You have to either cool hydrogen to ridiculously low temperatures like -250, or pressurize it to very, very high pressures like 700 bar or 1000 bar before you can sensibly move the hydrogen around if you want to transport it from a place A to place B. However, it has some good things. It has very high energy density, one of the highest energy density in terms of energy per unit mass. But because of the density, its energy per unit volume is pretty low. And it has some interesting other properties. So, how do you tame this beast, and what can you do with it? India has a national green hydrogen mission, like many countries has. Fairly good amount of money, about $2.2 billion invested in the mission. A lot of PLI incentive schemes, waivers for transporting green electricity to make hydrogen. A lot of nice things have been done. And therefore, there's a big euphoria about producing hydrogen, storing, transporting hydrogen, and utilizing hydrogen. Ultimately, it's all the economics that will determine where hydrogen will really be used. But there are some emerging opportunities that India must catch on to, and those are the only ones that I want to speak about today. So one of the things that we are looking at NCL is chemical industry. We are a national chemical laboratory, so we are embedded in the chemical ecosystem in the country, and we're looking at chemical industry. Now, one of the big factors, so not the refining part, the downstream of refining, downstream of what comes out of a refinery. India has about 15,000 chemical companies, ranging from 75,000 crores on pharma kind of companies to 50 crore companies, small ones spread around MSMEs in any chemical belt that you can go and visit. You'll find all of them there. This is a very interesting and a very strategic industry for India, because 65% of the chemicals and the products that come out of this chemical industry are exported, which means they are sold in markets outside, markets where carbon economy is already kicked in. You can sell green products there and get carbon credits in cash. And so this is an interesting industry where hydrogen is used as a feedstock. Hydrogenation is a platform chemistry that is used. And honestly, nobody in India knows how much hydrogen is actually used in this industry across the country. My belief, my calculations is about 150 kilotons per annum. Now, it's not a very large volume, but it's not a very small volume as well. 150 kilotons per annum is a very nice volume to kickstart the hydrogen economy. But what is most interesting about it is today, all of that 150 kilotons per annum that is consumed all of it is gray hydrogen. And how much price do they pay for it? Just, anyone from IIT Madras doing hydrogenation knows how much we pay for a hydrogen cylinder. It can run anywhere between $4 to $6 per kg. Gray hydrogen bought at $4 to $6 per kg. This number is interesting because this is exactly the kind of numbers that India today can produce green hydrogen at. So if you supply green hydrogen to these companies at the same price point, they don't have to pay anything more. They can move from gray to green very easily. And for them, it makes imminent sense because, as I said, they can make green chemicals, sell them in markets outside, and earn carbon credits. So when we realized this, we sort of started talking about it, and this idea has been lapped up. We are setting up our first hydrogen valley in Pune, and we've already received requests from companies in Gujarat, in Himachal Pradesh, in Tamil Nadu, and in Uttar Pradesh to come and set up these kind of plants where hydrogen is made in localities where chemical industry exists, and replace their gray hydrogen with green hydrogen. So this is an interesting low-hanging fruit for India. It's sufficient volume for us to get kick-starting the hydrogen economy. The other interesting emerging opportunity for India is data. So as we all consume data, huge amounts of data, all financial transactions, entertainment, education, land records, all your UIDs, Aadhaar, everything is data today. And it's stored in servers, not sitting in India, but outside India. So there's a push from the government to localize all our data. And as India, becomes more and more of a Viksit, developed country, the amount of data that is going to be generated is humongous. There are some interesting reports, both from consulting companies as well as from Niti Aayog and others, which have, you read them, you get the numbers of what kind of explosion in data consumption is going to happen in this country. And if we have to localize all that data, there's going to be a huge increase in data centers that is coming up. By 2030, it's estimated about 1.8 gigawatts of power required to run just these data centers, just 5 years from now. That's the estimate. And if all of that power, 1.8 gigawatts, is coming from fossil, then you can imagine the kind of emissions that we are talking about. And this is one of those opportunities for India where, while we make progress to digitized economy, we can also adopt the path of sustainable digitization. And therefore, adopting green technologies to power large data centers or smaller but large number of data centers is an exciting option for India. And this is again one of those areas where, in the window of about 2 to 10 megawatt data centers, it's sufficient data center to go in every district in this country where a lot of data is getting generated. This is a nice window where some of the hydrogen technologies come in very handy. There's a technology that uses hydrogen called a solid oxide fuel cell. It runs at high temperature, about 850 degrees centigrade, runs 24/7, very, very efficient. But the good part is you can also valorize, you can monetize the heat that comes out, because very high quality heat, 850 degrees the operating temperature. The exhaust that comes out of the solid oxide fuel cell itself is about 300 degrees, very high quality heat. And what the data center really needs is two things. One, very, very reliable electricity. A tier 4 data center should be operational 99.9997%. That is, you can't even have a second breakdown of the data center. So you need extremely reliable electricity 24/7. And you need a lot of cooling, because all the data centers, the servers, and more and more, as we go to more AI, that means more GPU servers, more high computing servers, therefore more heat, and therefore they have to be cooled. So the data center, at least 20 to 30% of the power consumption of a data center is used for cooling. Use cases for hydrogen, using in fertilizers, in refining, and so on and so forth. Those are difficult because the economics don't always work out unless the government puts in mandates and gives subsidies and so on. But there are one more interesting opportunity in the fuel sector that is emerging, and that is in the what is called the e-methanol. Now, e-methanol is very, very expensive. E-methanol is made by taking captured CO2, combining it with hydrogen to make methanol. Captured CO2 expensive, green hydrogen expensive, therefore e-methanol very expensive. And yet, there's a huge trading that is happening today in e-methanol. There is a green corridor that has been set up between Singapore and the port of Rotterdam, and it's only meant to carry green fuels, or e-fuels as they are called. There are two ports in India which are on that map, the port of Paradip and the port of Kandla. This might be also Tuticorin, but these are the three ports where if green or e-methanol is produced, offtake is available. Countries willing to pay the price of green methanol. So, when the iron is hot, hit it, use it. We have the opportunity today for India. These are the three ports where India strategically has named them as the hydrogen hubs of India, and for good reasons. And therefore, these are also the ports where a lot of CO2 is available, and fairly, well, the cheapest form of CO2 is available. For example, a lot of distilleries in Orissa, close to Paradip, as they produce ethanol, they produce CO2, and that CO2 is about 90+% pure already, right? It's coming out of bioreactors. That CO2 can be easily and more effectively, viably captured and converted into e-methanol by using hydrogen. So these are interesting options for India. In the emerging story of hydrogen, I thought I will only share some of these interesting aspects. The rest of the hydrogen stories, I think everybody knows, and in this auditorium itself, I gave a long talk on hydrogen, so I'm not going to repeat them. So thank you so much for listening.